Hi everyone, this is GKCS. Today we are talking about a remote code execution engine. What this does is it takes code from different users across the world and tests whether this code is passing according to the problem statement. So you have some test cases over here. In case they pass, then you get accepted, which is AC, and if you get a wrong answer, then well, the code is not accepted, and that is also recorded. Now this is a very common scenario when you have competitive programming contests, or if you have interviews, or if you're practicing for interviews. You want your code to be submitted to a system which can actually evaluate it and then give you a result. So how do we do this efficiently? Well, we can start off with something very simple. We can have our own server actually input this file. So you can have a code upload, which we will be running on our server immediately. Let's say this is a Python file. So you'll have something like Python and then the file name that the user has actually uploaded. This needs to have some sort of an input. So you have something like test.txt. Okay, this is an input to this file, and the output has to be checked with what is known to be correct. So for this test case, you need to have known outputs which have to be checked against this file. Okay, that's a pretty simple operation. All you're doing is you're actually executing a command. You're waiting for this file to check itself against this file, and then if that is true, then you store it in a database over here as either accepted if the files match, or a reject. Now there's a lot of problems with this kind of a simple approach. The biggest issue is that when you get a request from a user, you're immediately executing and then you're getting a response. What if you have a contest where there's thousands of users submitting files at the same time? That can be solved to some extent with rate limiting, which basically means that if you can't handle that much, start dropping or start blocking requests. But the user experience in such a situation is very bad. It's also not fair in a contest to have your code not go through. I mean, logically you thought through everything and then you don't win the contest because of rate limiting is not a good idea. So in our case, rate limiting is not something that we want to do. It's a last ditch effort. What are the other things we can do? Well, we are seeing that we cannot meet the requirements of thousands of users at any given point of time. But we can process these requests slowly. So if I had something like a message queue where my users would take their code and input them into this server. So we are actually storing files in our server for now, but we are not executing them at the same time because executing requires processing power. Instead, what we do is we actually just add an event to this message queue with the relevant details of this user's code. So for example, every event here, E, will have the user who actually uploaded this file, the code URL. So that would be a file URL, basically pointing to a file in some other system. You're not going to be storing it in your server actually. You're probably going to store it in something like S3. Okay, a distributed file system is a good idea to store files. So we are seeing that now instead of processing files immediately, we are actually acknowledging the upload of a file immediately to a user. They know that the file has been uploaded, so they are happy about it. At the same time, we are also publishing to this event bus an event with the relevant details to execute this file at some point in time later. Okay, so what we have done is we have made this system asynchronous, which is good because you don't have the processing power to actually handle synchronous requests in certain cases. Now our server is going to be processing these requests, these events, one by one according to its capacity. So the server is publishing to this bus and the server is subscribing to this bus. Internally, of course, this server is going to be far more complicated. It's probably going to have a lot of microservices, but we are taking the 10,000 feet view where we just have a single black box which is doing all this. If required, we'll split this further into components. Okay, so like we said, we are subscribed to these events, which means that you're processing these events one by one from the tail of the queue. Eventually, you're going to come over here to the event over here. And in fact, new events will keep getting added, so it will keep increasing on this side. Eventually, when you get this event, you're going to execute this event through a command on the server. You execute the Python command, given an input, and you get some output. The good thing is that whether it's Python or Java or whatever, you're pushing in the same input, the same test cases, and expecting the same output for all these files. Finally, you're going to be checking whether the output matches the required test case output, and depending on that, you're going to be persisting to this database. This seems reasonable, but there is one critical component when it comes to executing a piece of code on your server, and that is security. For example, if someone has some malicious code in this file, you don't want this malicious code being run on your server with all the rest of the users' files also over here. I mean, what if this is the worst case? Of course, you should avoid this in general, but what if they have something like rm minus rf? Things that engineers like me like to do. So to avoid this, to avoid the problem of illegal code executing or the capacity of the server being exceeded, what you can do is you can use something called virtualization. You create a virtual operating system in which the code that has been uploaded can run. So in this, when the code executes, nothing bad can happen. I mean, the worst case, this operating system will crash, but so what? You just return them a wrong answer anyway, or you give them an illegal exception. With this idea, we can do even better. We can, instead of using virtualization, use something called containers. Okay, you might have heard of this, Kubernetes, Docker. There's various ways in which you can create containers. But the general idea is this, that you don't need an entire virtual operating system to be created every time new code has to be executed on your server. It would be much better if you could just create a container for that code's execution and then check the results the same way, and then depend on that, you can publish in the database, yes or no. Of course, this data is also going to be queried by these users, but that's not our concern. That's a separate API. So you might have a separate service which is actually pulling data from this database. Like you can see, we haven't focused on authorization, we haven't focused on profile creation, on session handling, nothing. All we are focusing on is the core problem over here. And that's the reason why this video is short, because even in an interview, actually, you can't afford to like beat around the bush and talk about, oh, I'm going to create an authentication service and a gateway and stuff like that, if you have something which is as clear as a remote code execution engine. The core problem, the absolute core problem, is that you need a job scheduler so that you don't overload your services. You need a container so you don't overload your services, and there is security, and that's it. Okay. So if you have any doubts or suggestions on this, you can let me know in the comments below. If, of course, you're seeing that there's a lot more nuances when it comes to this kind of a system, do let me know. We'll have an interesting discussion. I will be posting more videos like this, so subscribing is a good idea. And of course, if you're looking for more detailed videos on system design, you can head to interviewready.io. I'll see you next time.